Hi everyone. So today I'm going to teach you how to do a web component. So we'll start with the basics, and then we'll move up from the very beginning. And so what this web component is going to do is we'll start with just a header, just some sort of element that outputs some text, and then we're going to add in an attribute. We'll watch that attribute and then allow the text to be updated from that attribute. We might even go crazy and update that attribute dynamically and see what happens. So a web component is basically a custom element that you define in HTML. So in this case, we have this element called special header. If we were to put something in here now, there's no understanding from the browser what a special header is. So it converts it essentially to a div. And here, this is represented as a div. It's a block element, so that's how that looks. But if we were to add in, say, a web component, and what we'll do is we'll call it class special header. Now, web components always extends HTML element. So this is what our custom class looks like. But we have to still define to the browser that we've created this class and that it's going to handle the special header element. So we do custom elements, define, and then we call it special header. Now, the second parameter to this is the class that we want the special header element to use. So this still isn't enough to get the browser to render the special header. We have to give it some extra information. So we'll do the bare minimum. We're going to add in constructor. Now, as in with class implementations, we always have a constructor. The constructor always calls super if we needed to. Now, it is possible to create this without a constructor, but I don't recommend it because there's some additional details that you do get with a constructor. You can make a constructor have, say, almost nothing in it, just a super call, or you can add in some extra functionality here. So let's talk about the constructor a little bit. In common practice, what I'm going to show you is what, say, like a junior developer might do from the very beginning, and then we're going to work on with the more standardized programming practices. But common practice is to, in your constructor, you would set up some variables. You would make a couple maybe API requests or something like that that would retrieve variables or do some extra data manipulation or whatever you want. But you would normally not write your HTML out within the constructor. So that's kind of an anti-pattern, is to do what I'm going to show here. So what we want to do is work more towards the correct pattern. So we'll continue on with the programming now. So our super is called, and then we do let text equals, and then we can do our template literal, and we call h2. This is our special header, and then we say hello world. All right. So now with our template literal, we have the ability to add in or inject variables with maybe person. Let's say person here. Let's move this and say const person equals, and then we're going to call it world. So this kind of goes to show you what the template literals can do. Let's just say here we call that let, but it really is a const. And now what do we do with this? We have our text, we have our person in there, and then we want to do this dot inner HTML equals text. So now we have this special header component, and it should render, if I've done everything right, it should render Oh, did it capitalize that? There we go. Sorry, had a capital C in there. So now it renders hello world. So you can see that we have a variable in there. We have our h2 element, which is rendered as the h2 here. We use this.innerHTML. Now you'll kind of ask yourself, where did I know how to use innerHTML? So that comes from the HTML element. Basically anything that works on a standard HTML element. So if you can imagine doing something on a div, you would have innerHTML, you would have class list, you would have inner text. Those types of properties are all on this. So we get the benefit of having basically all of the regular element properties on our class as well. So that's where this super constructor kind of helps inherit everything. But again, this is an anti-pattern. We don't want to develop it this way. We want to do something a little bit better. So how do I develop it where I could say text equals hello world, hello universe, right? I want us to say universe instead of world. So right now we don't do anything with this text. We need to add in some extra properties. So in our class, we're going to add in, we're going to say static get observed attributes. And this is a function that is defined on custom elements or web components that should return an array of attributes that we want to look at. So here this one returns the array of text. So that's our observed attribute. What does it mean, observed attributes? So what we're doing is we're observing this, or we're telling the web component that it needs to keep a watch on the text attribute, and then when the text attribute changes, then we need to execute some other function. So that other function is under our constructor. We'll do attribute changed callback. And typically there's a name property, there's an old value, and a new value. So what's great about this is that we know which attribute changed. We know what the old value was and what the new value was. We can compare them to see what changed within those, whether we need to re-render or do something like that. And we can say, so in this case, if any of the attributes that we're watching changes, we just want to re-render. But we can't do that with the constructor developed in this way. So we kind of have a problem here that we've created a class with a constructor that was developed in a way that isn't necessarily renderable. So in other systems like, say, React, using the class-based components, you would have a render function. I want to create something that has that same render function. So we're going to call this render, and then I want to move this text down to the render function. So now whenever the attribute changes, I'm going to call render. And that should pull in the new attribute. So we have this person property, which if we were to create a variable on the class, we would say this.person equals world. So that's one way to do it. But we don't want to use a variable on the class, we want to use the observed attribute. So we want to have a getter. So we would say get text. So this get text represents this observed attribute. So basically any observed attribute that we have here, we should also have a getter. And then this getter is going to be return this dot get attribute, and we're going to say text. You can also say have an or clause in there in case the text attribute isn't set. So you could say something like hello world. All right. So now we have our getter. Instead of calling person here, we're going to call this .text. And notice I didn't use a parens here. I'm just using the property. So with getters and setters, if we were to use a setter, set text to value, and then this would go away, and this would be value here. So with getters and setters, you only call them like a variable. So this dot text equals some value, like so. So this calls a setter, and this one here calls the getter. So if everything worked, then we should see the render function executing. However, the constructor is not doing anything. So you notice that the constructor is just calling super. We have an attribute change callback, but the attribute is set from the very beginning. We have our getter for the text, that returns the attribute, and we have a render function that's not being executed. So how do we get this render function to execute? And the very simple explanation to that is that we need a connected callback. So let's do this below the constructor. So the connected callback is always async, meaning that it executes asynchronously from the browser's render cycle, so that it doesn't block the rendering of the web page, and this connected callback is executed whenever the browser runs the special header. So if I did this right, we should see this .innerHTML equals text, and there we go. So there we've input our text to universe. We have our getter returning that property. If we didn't put anything in here, then it should say world, and you can see how that works. So I want to set that back to universe, and now let's do something a little bit tricky. Now we saw that this was an observed attribute. We have our connected callback, which calls that initial render function. The alternative to the connected callback is doing something like this, which again goes back to that anti-pattern. You don't necessarily want to do this. Even though it's allowed, you could do it, it works fine. Really, the connected callback is where you want to put that render call, because this is what's executed when the web component gets attached to the DOM. So there's also a callback for disconnected. So in a similar vein, if you did some processes that maybe added event listeners or something like that, and you need to remove those event listeners that you created, you do a disconnected callback. And say clean up event listeners, right? So this disconnected callback is used for cleaning up things that would potentially cause some sort of memory leak, if you will. So since we're not creating event listeners, we don't necessarily need the disconnected callback, but it's good to know. It's good to know that it's available for us. So now I mentioned that I want to do something a little special here with this. So we had our observed attributes as text. So in my JavaScript code, normally you wouldn't do something like this, but I want to do document.get, let's do query selector, header. So this is what's really great about these custom components, is that you can do normal JavaScript query selectors on them. It's not You don't have to deal with refs. You don't have to deal with any sort of custom components in React or Angular or anything like that. You could actually do query selectors directly on the custom component. The set attribute text, and I'm going to say county. So if I got that right, it should say county. And it doesn't. And it might be because it's rendering this afterwards. Oh, it does say county there. So we can see that it updated, but it didn't re-render it. And that could be because it's asynchronous. So I believe what's going on here is this connected callback is asynchronous, so the attribute change callback might not be working. So I want to set interval. Let's do this in an interval. And I want to do new date dot get time. And if I did this right, it should be changing. That's why. Render is not defined. Because here, the attribute change callback is not calling this dot render. So if you saw that and you made a note of it, good for you. Give yourself a pat on the back. You deserve an award for that, because I completely missed that, but good thing we can use our console for any sort of error. And if you notice, the console actually provides the line number and everything too. So this is what's great about these two, is that we can set attributes. It has listener setup. They are fast. So like here, you notice that I set this to 500. Well, let's set it to 1. I want to see this thing change every millisecond. Now, if I can see it change every millisecond, then that'd be incredible, because I don't even think React can do a millisecond change like this. This is way faster than any rendering for React or Vue.js or anything. Let's do, can we do like 0.05? Oops. That seems to work. Let's do 0. Let's try to see what we can get out of this. And there you go. Now that's happening every basically iteration of the CPU. This thing's querying the special header and setting the attribute for text. How do we speed this up a little bit more? Well, we could do this query selector outside of the set interval. Const my header like that. And now it doesn't have to do this lookup. It just does a set attribute. So it is as fast as possible now. So this is kind of custom code. Call that test code, showing you how fast these things can really run. I can get into some more explicit examples where we're rendering. There's one where React and Angular and Vue.js are being compared to each other with a table of basically random changes like this. But I think this goes to show you how fast these things can render, because they're just, you know, HTML elements. They're not React. You don't have to compile them down to anything or anything like that. And they give you this very clear life cycle to work with. The documentation is excellent. So yeah, I hope you like this. Let's go over real quick one more, or what we've learned. So we learned that in order to do web components, custom web components, we need a class. We need it to extend HTML element. In order to pass in attributes, we need a static getObservedAttributes, which returns an array of the attribute names. We need our constructor to call super, but since this web component really doesn't do anything, we don't need it because by default it's going to extend it and it's going to call super. If we were to do other things within the constructor, if we were to do other things in here, say like this dot property equals hello, then this is a great example of why you would need a constructor. But because this component's so simple, we could delete this. The next bit is that we need a connected callback, and this is for proper function definition. I always like to create this render function, which can be called within the connected callback, and it could also be called anywhere else. So what I did here was in the attribute change callback, I call this .render. We can call other functions as well. So if, say, some attribute changes that needs API request to be made, then we can listen for that attribute change. We can inspect the name of the attribute, and then we can call an API and then render within the return response of that API. So those are very great options to do within the attribute change callback. So yeah, and going on, we have our getter for the text attribute. We always return this .getAttributeText. We can add additional getters for data stores or simple variables or something else. If there's a more complex example of a function that would return some property, you can create a getter for it. And what's great about this too is that this can be used by external components as well. So if you were to say, get attribute and then had a custom getter defined in here, then it can return that custom attribute as well. And then we have a render function, which you would set up your variable, or you would set up your text that you want to inject, and then you can call. There's two different ways to do this. In this example, I use inner HTML. It's a very simplistic way to do it, but you can certainly do document.create component, create element, and then I want to call that h2. And then, so const my h2. So you can see how this is very similar to the inner HTML one because it's such a simplistic example. And you can do this dot append child my h2. And the very first thing that we want to call here to clear out the previous text is that you saw just there. If I didn't call this like this, then every time it re-renders, it's going to execute or it's going to write the data into here. So I want to clear out the previous execution's text. So this would be an example of creating a custom element and then appending it as a child to this element. And the speed is roughly about the same for doing that. So really no speed difference. But yeah, and then we always have to you do this custom elements.define. Then we have our special header, which is the element that we're creating, and then we give it the class that we're working with. This extra code down here is just test code, and it shows you what we can do. So thanks.